In this scenario, we have acetylene gas being prepared by the reaction of calcium carbide with water. So calcium carbide is a solid, and it reacts with water in a 1:2 ratio to produce calcium hydroxide and this acetylene gas. We'd like to calculate the volume of this gas that's collected over water at these conditions. We have 20 degrees Celsius and 753 torr. We are reacting 1.524 grams of the calcium carbide. It also reminds us in this question that the vapor pressure of water is given in tables. So anytime we do a collection of gas over water, we're going to need to account for the vapor pressure of water. So we're at 20 degrees Celsius. So if I look back at my table at 20 degrees Celsius, which is listed at the bottom here, I know that my vapor pressure of water is 17.54 torr. There's a lot of information in this question, and it's going to be a multi-step problem. We're going to have 4 steps to solve. So let's make a list of all the information we have. We've got our mass of our calcium carbide. We've got our total pressure, the atmospheric pressure, and the vapor pressure of the water, which we'll be able to use to calculate the partial pressure of the acetylene gas. We're looking for the volume, and we have the temperature. So what I have kind of started here is I'm thinking about the fact that I want to use PV equals nRT to solve this problem. So I've made a list of my variables. To solve this, I'm going to need my moles. My list here is to help me to identify the pressure that I'm going to be able to apply to my ideal gas law. And my starting point is the fact that I've got my mass of calcium carbide. So thinking through the problem a little bit before I solve it, I've got the mass of my calcium carbide, and I ultimately want the volume of this gas. And so I'm ultimately going to want to use PV equals nRT in order to do that. So if we think through the steps in advance, we've got our mass here. If I have the moles of this, I'll be able to find the moles of my acetylene using stoichiometry, or the mole ratio. Then once I've determined all of the variables in this except for the volume, I'll be able to sub in and solve. So let's walk through the steps. Our first step is to take the mass of the calcium carbide that we are given, 1.524 grams, and solve for the moles. So I've done that by doing mass over molar mass. So this is my moles of my calcium carbide. Once I've got the moles of my calcium carbide, I can use my 1:1 ratio to identify that the moles of my acetylene gas is the same. Now to sub in and solve using PV equals nRT, I have the volume, that's what I'm looking for. I now have the moles, the R is a constant, and my temperature. So I just need the pressure of the gas, and then I'll be able to solve for the volume. So to solve for the pressure of the gas, I'm using Dalton's law. My partial pressure of my acetylene is 753.46 torr. Now, when I use the ideal gas law, I have my 2 R values, 8.314 and 0.08206. And I've decided that I want to use atmospheres, so I'm going to use the R value of 0.08206. So this is why I've converted my torr to atmospheres by dividing by 760, using that unit conversion of 1 ATM is equal to 760 torr. So my last step here is to sub into the ideal gas law and solve for volume. The volume, you'll remember when we use the ideal gas law, is reported in liters. And there's no specification in the question that I need to convert this to milliliters, but I chose to just because I have a better sense of what 591 milliliters is versus 0.5907 liters. But either one is correct as long as you report it to the correct number of significant digits, which in this case is 3.